So as we've already learned, there is a built-in process for developing IEPDs, for developing message specifications. So that's what we're going to talk about next. We're going to go through the various steps in the process, and one of those steps, mapping, we're going to spend a lot of time on because that's where all the technical details about NIEM come in. We're going to learn all about that stuff. So here we go into an overview of the process for developing a message specification. All right, so now that we've seen basically an introduction to NIEM, and we know what NIEM is, we know how it works, and we have a general idea how it's put together, let's switch gears a little bit and talk about the message spec side of it. The message spec / IEPD, and when you're looking at the IEPD, remember that that stands for Information Exchange Package Documentation. It's a mouthful. It made sense at the time when we came up with the term. This would have been 15 years ago. Made sense. It was in alignment with some government terminology at the time. But in retrospect, it's just not a really good name. Plus, how do you say it in a plural form? Information Exchange Package Documentations? Anyway, it's just a really bad word. It's a hard term. It doesn't work well. So we're changing over to message specification, which makes a lot more sense. What are we doing? We're defining what a message needs to look like. Well, that's a message specification. You'll see both terms used throughout the materials. You'll occasionally see IEPD alone in a diagram simply because we don't have the source for the diagram anymore and we would have to hack in additional text. But when you see them, they mean the same thing, same exact thing. What they're doing is defining an exchange. They're defining the payload document. They're defining the thing you're going to exchange. They're defining the liquid in the bottle, if you like that metaphor. It's made up of a bunch of artifacts. They're just documents. We call them artifacts, but they're just documents. Some of these documents are meant for humans to consume, so they're meant for humans to read and understand. Other of the artifacts are meant for computers primarily. Those would be the XML files, XML schema, things like that. We can look at them and understand them, but they're meant for computers. That's what XML is really meant for computers to understand, but we can still read them. And the whole process is all about coming up with these artifacts and describing what a message needs to look like. That's the whole idea. So there is a whole process behind all that. So let's take a look. I can't get the whole thing on one screen, but I'm going to try. Well, there's a bullet list and there's a diagram, and we're gonna go to the diagram. We're going to use the diagram. So we start at the top with scenario planning. And now each of these I'm going to talk about in detail. The map and model step there at about 4 o'clock on the dial, the map and model is a large topic, and that's going to take the bulk of our time for the whole training. But we're going to talk about each one of these in detail. So I'm just going to cover them very lightly right now. But scenario planning, that's figuring out what the exchange is about. Analyzing requirements, that's figuring out what the business level requirements are. What are the chunks of data at a business level that we are going to exchange? What are the needs of the exchange? Then map and model is actually going into NIEM and finding out how to represent those business things, business requirements as NIEM things. So how do we go and find them in NIEM? How do we represent these things in NIEM? Build and validate is actually making the schemas representing the business concepts being mapped to NIEM. So that's all about making schemas. Then there's assembling and documenting. That's getting all the documentation together and putting it all together. And then the last step is implementation. Implementation is actually writing the code. Now I'm going to be upfront. We are not going to cover implementation in detail because that's very, very specific to your environment and how you do things. We are going to talk about it a little, but it's not going to be a big topic. There's just only so much I can tell you about implementation because I don't know your system. I don't know how you develop software. I don't know your needs. I don't know your requirements. There's just not a lot I can tell you about it. The good thing is, though, that the NIEM is just XML or JSON if you're going the JSON route, and you don't have to do anything special for it. It's just XML. Each of these steps produces artifacts, and then these artifacts go together to become the IEPD. So I like to say scenario planning, you come out of that with a clue as to what you're doing, although you probably come out with some documents documenting that too. The analyzing requirements step, where we look at what our business requirements are, that generally produces UML diagrams. And we're going to have a quick intro to UML diagrams so you know the variety of them and you know the ones that are most important for NIEM work. the mapping and modeling step, you end up with a mapping spreadsheet. And this mapping spreadsheet literally lists your business requirements down one side and what those requirements become in NIEM on the other. And you've got options there. There's not one true mapping spreadsheet. You can do this in a lot of different ways. Then we get to build and validate. That's where you make the schemas and instance documents that match those schemas. And so that's what comes out of there is schema documents. Assemble and document, you get textual documents out of there. So you've got documentation about the exchange that's meant for humans to read. And then finally, when you implement, you end up with code and a working system. You'll notice the diagram is a circle because after you've implemented, it pops back into scenario planning. Well, that's because the things you learn one cycle is going to help you when you later make a new version down the road, and you'll go back into scenario planning knowing what you know, and it feeds itself. But this also represents how NIEM works as well, in that you make a message spec, and as you do that, you're going to find things that you thought were in NIEM that weren't, and you think they should have been there. Well, guess what you can do? You can submit that stuff to the NBAC. Remember the Business Architecture Committee from the organization diagram. You can submit that content to them and say, you know, we really thought this stuff should be in NIEM. And they'll look at it, and if they agree, it'll end up in NIEM. And that is literally how things get into NIEM. People try to use it, they find there are holes in it where the things they thought they needed weren't there, and that's how new content gets added to NIEM. People in the real world trying to use it find deficiencies and communicate that. So NIEM itself is a circular sort of iterative process. Now you look at that diagram, and it looks very simple. The diagram above the circle, it looks like a really nice, clear process, right? You know, you're going to agree to share, and you do some scenario planning, and you get source documents, and you do some requirement analysis, and that gets you diagrams, and you do some mapping, and that gets you a mapping spreadsheet, and you use that to create schemas, and that gives you schemas, and you assemble them together into the message spec. I used IEPD package here, but either one, and then finally you implement it, and you get a system. But you know, here's how it really works in the real world. In the real world, it becomes an iterative process. So, you know, you may get down to, I did my requirements and now I started mapping things and I realize, oh, I missed some information. So I have to back up. I have to update my UML diagrams and then continue into the mapping. And then maybe I realize I missed a whole source document that tells me interesting business things that I needed to know. I got to go back 2 steps, got to relook at my requirements. I get new diagrams out of it, go back into the mapping. And then maybe I go and I start making schemas and I realize I did something weird in my mapping that I can't do well in schema, and I back up and I change my mapping. And then I go and I make schemas and then I assemble it together. And then I implement, and maybe even then at implementation I find problems and I have to go back several steps. It's like a leaf going down a creek. And you throw a leaf in a creek and the leaf goes in one end and it's going to come out the other. But along the way, it's going to get hung up on rocks, it's going to hit little eddies, it's going to hit little back currents, things are going to delay it, things are going to make it change direction, and that's just how any real-life process is. So that's just something to keep in mind. We would all love for our development processes to be this straight line, but in reality, they're going to be more like this. They're going to be iterative. I worked on the first version of the wrap sheet specification for NLETs, and this was for exchanging wrap sheet information to try to reduce recidivism. And I went through like 30 to 40 iterations of the exchange. And I have them all in a folder, and they're just numbered draft 1, draft 2, draft 36, draft 37, draft 38, and I forget the actual number. It's either 36 or 42. For some reason, I think that. But I don't know. I haven't gone back into my old archives. But 30 to 40 iterations, 30 to 40 drafts as we learn new things and we looked at the outcomes and we realized we had to make changes. And that's just how the process works. It's iterative. So, you don't worry about that. You work your way through it and you get out in the end, but you just have to keep in mind that you're going to have setbacks. The documentation pieces that go into one of these things, well, there's several of them. And I like to break them down into documentation that tells you about stuff and definitional that defines stuff. And some of these you don't know what they are, and that's okay. We'll find out later. You'll find out, well, a lot with this the subject matter that we have to talk about things before we get to explain them, because I can't explain everything at once. We got to pick an order to explain things in. So you're going to get used to me saying, you'll learn about this later, because I just can't hide everything until you learn about it. So a lot of these you don't know what they are, but that's okay, because you will by the end of the class. So you got master documentation. That's typically a Word document, and that's just a document that tells you about how the exchange is supposed to work. Who are the parties, who's involved, things like that. There is something called a catalog, an IEPD catalog, and that's an XML file, and that tells you everything about the spec at a computer level for computers to deal with. So it's going to have metadata about the exchange, but it's also going to have a list of all the files that are part of the message spec and what the different files do. You have a change log that'll say how the versions have gone and how the changes that have been made. You'll have a README as a place for people to start, just to let them know what's going on. You'll have something called a conformance assertion, where you tell them why you think your work is NIEM conformant. And then you've got definitional artifacts. The definitional artifacts, those actually define the payload document, or at least help define the payload document. You'll see a want list, and we won't cover want lists for a while, but we'll get to them. We'll get to all of these. These are all kind of later topics. But there's a want list that defines what it is you took out of NIEM. There's a number of different schemas involved. There's subsets and extensions and exchanges and sample instances, and we'll learn more about all of these. And there's XML catalogs to help something that's validating your XML put things together in the right order. So there are a bunch of different artifacts, and these all come together to make a message specification, to make an IEPD. So knowing that the process isn't straight line, even though we're going to look at it as straight line, and knowing that the end result is a bunch of artifacts that basically get bundled together, let's start actually looking at the steps. So the first step is scenario planning. So scenario planning, this is where you decide what the exchange is about. You decide who the exchange partners are. You decide who are the stakeholders. You decide that you figure out what it's going to be about. The idea here is to basically get your ducks in a row, figure out what's going on, figure out what you're going to do. Communication is really key at this point. The little sequence diagram that I have there is a real-world diagram. Okay, this is real world. I did training once in Hawaii, and at that time the training was very long. It was 4.5 days. And you spent the last half day basically making a mini message specification, mini IEPD at the time. And so I had these wonderful Hawaiian folks there, and they were from 2 different offices, and these offices needed to exchange information. They were already doing it, but they needed to do it in a better way, so they were looking at NIEM. And one group sat on one side, and the other group sat on the other side. You know, it was like a wedding where the bride's all on one side, family is on one side, and the groom is on the other. And we started talking about this exchange they wanted to do. And the folks who were sending the information, said, so right now we send you A, B, and C. Now I don't remember what A, B, and C were, but they were 3 pieces of information. And the other side of the room said, well, we don't use C, we throw it away. We don't have a use for it, we really need D. And the people who were sending it just went, what? C is really hard to generate, D is easy, we could have given you D all along. And the people receiving it just kind of shrugged like, well, we don't need C. We don't know why you were giving it to us. And these were 2 offices in the same division who were exchanging information in a clunky way, and they had never sat down together and just talked about the basic needs. Real world example. Hilarious looking from the outside. I think they were a little embarrassed from the inside, but now they knew at least that what they really needed was A, B, and D. And just sitting down and going through that exercise improved their lives because now they were sending the correct information and not being inefficient trying to generate information that wasn't even needed. Existing exchanges you might find or other documentation you have can help with this. So you might have documentation from within your organization about this exchange. A lot of times exchanges start as paper exchanges. There's already an existing exchange, but it's done via paper form, and you're trying to make that an electronic exchange. Well, then guess what? That paper form is a really good source of information about what you need. I've done plenty of message specs that started with a paper form, and we extracted the information from the paper form. That's a very, very typical scenario. You might also find similar exchanges in NIEM repositories. Now, there's a huge caveat to that. I mentioned it earlier, we're in kind of a period of flux where there are existing repositories, but they're very old. There are new repositories that are just being spun up literally as we speak, as I speak. I'm not sure when you're listening to me, but from the time that I'm speaking at, they're just starting to get spun up. So for me right now, we're in a lull in between repositories. I don't have a good place to go to look for prior work. But as the new repositories come online and as IEPDs, as message specs get deposited in those repositories, then that becomes a resource for you to look for existing work and work from there. There's also a community to draw from, and that's what the little diagram is about. You're making a message spec. See, this one just says IEPD because there's just not enough room in that little circle to put message specification. But you're a participant in NIEM. You're using NIEM. You're a participant. You're part of the community. And if you need help, the community is there to help. There's a Contact Us page on the NIEM site. You can email me and I can get you connected to the right people. There is a community of people doing NIEM work who will be happy to help, happy to provide assistance. So you're part of a community. You can draw from that community. So I talked about existing documentation as a start. Things like current technical architecture documents for all the Exchange partners, that can really help. And even though NIEM doesn't care about your internal data representation, doesn't care about how your database is set up, that's still a good source of information about what things you have access to and how you're going to draw those out. So, existing paper forms are great, but also, how is my database set up and what information do I have at my disposal and what can I get together easily and what can't I? That's all important information. You want stakeholders involved in the Exchange because they're stakeholders and they're subject matter experts and they'll have ideas to share. Security, privacy, and other policy-related concerns associated with the Exchange are very important. I come from a justice background. Via a juvenile justice focus. Juvenile justice is very, very privacy-oriented to the point where it's hard to tell them about NIEM because their first reaction is we can't share that information because these are kids. Privacy is important. Security is important. DoD is running the NIEM program. DoD cares a lot about security. There are other policy-related concerns. Remember the scope diagrams. These things are all out of scope for NIEM. That doesn't mean they're not important. You still have to consider them, and you can still put information about them in a message specification, even though they're out of scope of NIEM. So especially if you have information in an Exchange that has certain security implications, you want to add that to the documentation, and you want to look at that ahead of time while you're planning all this out. You also want to look at technical characteristics of the Exchange. What kind of data is being shared, how many objects, that'll let you kind of figure out level of effort. If you're doing an Exchange with a dozen objects, that's really quick to throw together. If you're doing an Exchange with 120 objects, which is not uncommon, that's a little more work. If it's 3 times that, that's a lot more work. So you want to have an idea of the size and scope. You want to take a look at the structure of your data, logically and physically. How is your data put together now so that you have a handle for how you can then transform that into NIEM conformance stuff. And you also want to look at whether you're going to have any external standards you can draw upon. NIEM has functionality to include external standards if they're represented in XML, and we're going to talk about that. That's not something that I see used an awful lot, but if you have an external standard you want to incorporate in NIEM work, there are mechanisms for doing so. So that in a nutshell was scenario planning. It's get your ducks in a row, figure out what you're doing. That's what it's about. What are you doing? Get your documentation together that helps you understand what the business requirements are. So that gets us to the next step. That gets us to analyzing requirements. So analyzing requirements is all about diagrams, typically. Not just, but typically diagrams. UML diagrams are often used. Now I'm going to show you a number of potential UML diagrams. Most of these aren't used a lot, but people do use them. So it's just a quick overview of some of them, and then we'll get into a little more detail on class diagrams, which is really what you use typically in NIEM work. But we're going to talk about how you analyze the requirement, or not how, but how you, you're going to look at your requirements and analyze them, but ways you can document those for the next steps. So first, some sample UML diagrams, just to let you see what they look like. Now these are not specific to the example we're going to use throughout the training. They're just kind of, here's an example of a use case diagram. Additionally, the blue callouts are not part of the diagram. The red circles are not part of the diagram. Those are all call-outs. But the bottom line here is you have a bunch of actors. You have a traveler in one corner and an airport officer, and it's basically a bird's eye view, high-level view of what's going on here. We've got a traveler, and they're submitting documents, and an officer is reviewing them and sending off a query to some application that sends a query off to another application, which returns results. And each one of those red circles is potentially an exchange of information, potentially something that you would define in a message specification. If you want to go in a little deeper, there's a business process diagram. I always like business process diagrams. They have this thing called swim lanes. So each of the actors in the above diagram has their own swim lane, and you can follow along and see what each actor does and follow the path of the process through. There's a start circle on the left. The ones at the right are the endpoints, and there's a decision point in the middle, and you can just follow that along. The traveler submits documents to the officer, who sends off a query to a system, which sends off another query. The results come back, and the officer makes a decision, and then the person either leaves or else they get held for an investigation. This gives you more of a flow through the process, organized by actor. I've always been a big fan of these. Now, you don't see a lot of these in NIEM work, but you probably should, right? You really probably should. And a number of these gray arrows, those are actual exchanges. When that officer sends a query off to the airport screening application, that's a query. That's an exchange of information. And when the results come back, that's another exchange of information. So you can use these kind of diagrams to help ID where information exchanges occur. If you want to go one level deeper, you can go to sequence diagrams. And sequence diagrams list the actors along the top and the actual queries. So here's a screening application that sends the query to a customs application that sends the results back, and then there's an airport history application at the end to record this, and they send a little query there saying record this, and they send a result saying we recorded it. And here very explicitly, each one of these gray arrows is an exchange. It's an exchange of information from one system to another. And this would be another way to show, especially if you're doing a message spec with more than one exchange message, which is very, very common, especially with queries and results. You send a query, you get a response back, and you wrap that all up in a message specification. Very common use case. Sequence diagrams can really help show you where those are and who are the exact exchange parties for each of those exchanges. So these are all good UML diagrams. They don't get used all that often in message specs, and they really should. I would encourage, if you're going to be doing this kind of work, to include this kind of documentation. But when it comes to message specs, when it comes to IEPDs, what we typically see are class diagrams, UML class diagrams. They're the bread and butter of NIEM work. They're a way of showing the different chunks of information conceptually and how they fit together. And you have a choice on how you want to do your UML diagram. You can orient your UML towards business terms and objects. So you can use the terms that the business people, the subject matter experts, use to describe the information. I like this approach because it's better for gaining consensus, because the information is all there in the terminology and the representations and the relationships that the business people understand. So you can get them to sign off and say, yes, these are the parts of our exchange. This is what is important. But you can also make these oriented towards the final NIEM terms and objects, essentially preloading the mapping step. And if you're really good at NIEM, you can do this. You can start, instead of starting at business level stuff and mapping that to NIEM, you can kind of do a lot of the mapping in your head and represent it in UML. Now, I don't like to do that because I think it makes it harder for business people to understand. But some developers do it this way. So I want to show you both UML, and I'll explain why I do business oriented and work my way to the NIEM oriented rather than starting at NIEM oriented. So this is the UML that represents the sample IEPD that we're going to be using for the rest of the class. For the rest of this training, we're going to be using this. It's a crash driver information. It's information about the driver in a crash. It's not specifically about the crash itself. It's not a general exchange about the crash. It's specifically about the crash driver. It's called crash driver info. Now, if you aren't familiar with class diagrams, you're looking at one, and it's pretty simple once you know what all the little arrow types mean. So each one of these boxes is called a class. That's what the C in the circle means. Some forms, UML is flexible. Some people would say person class and driver class and charge class. Other people have an icon representing a class. The software I'm using uses a big C to represent these are classes. I like that, so I'm using this. But there are alternatives to it. Each box represents the concept of an object, not a specific object. So that box that says person represents the concept of a person, not an individual person. So if I had 5 different people as part of this exchange, the UML still just shows one person object. It shows conceptually what a person is and what a person is made out of in terms of data. So in this case, we have the concept of a person with a birth date, a first name, a middle name, and a last name. Down at the lower left, we have a driver. The concept of a driver. The driver has a driver's license number and an email address. That seems a little odd, right? Well, we're going to be a little odd. This is an example to exercise various things in NIEM, and one of the things we need to show you how to do is to add new things to existing objects. So we're going to say in this particular exchange, we talked to our business folks and they told us, yeah, we want to start putting email addresses on driver's licenses. So okay, cool, we're going to do that. The injured person box, that's the concept of an injured person with an injury description, a severity code, an injury privacy code as to whether this information about them is private or not, and a through window Boolean, which is an homage to my wife who actually went through the front windshield of a Volkswagen Beetle when she was a baby. Received just a chunk of glass in her head that left a small scar. Other than that, unhurt, but in homage to her, we're going to have a through window indicator that indicates whether this injured person went through the window or not. Similarly, we have a class for the charge with a description, whether or not it's a felony and whether or not it's criminal information. And then we have a crash in the lower right. That's going to have a date for the crash and coordinates where the crash occurred. And then we have the crash info itself, crash driver info, and that's going to be a wrapper. Now let me explain the arrows. So the arrow from driver to person with the triangular arrowhead that's open, it's not filled in, that represents a specialization. That's the driver class saying, I'm a special kind of person. And what that means is that that driver will also inherit a birth date, a first name, a middle name, and a last name. So in this UML, this is saying a driver is a special kind of person that has all the person stuff and adds a driver's license number and an email address. Same for the injured person. The injured person is a special kind of person, so they inherit the birth date, first, middle, and last name, and they add on all the stuff about injuries and whether they went through the window. The charge, then the crash, those things are separate things all on their own. Now you'll see a double-ended arrow between the person and the charge. That's indicating a generic association between them. There's some sort of relationship there. We're not giving it any specifics, but it just relates a person to a charge. And then finally you have those weird lines with the diamond ends on them. And so all the 4 things at the bottom all point out up to the crash driver info with these open diamond arrowheads essentially. What those represent is that crash driver info is made up of these 4 things, and the open diamond means that each of those 4 things is a standalone concept on its own. So if these were things that make up crash driver info but don't make sense on their own as separate objects, they'd be filled in diamonds. But they're open diamonds. This is called an aggregation. It's saying crash driver info is an aggregation of those 4 things because those 4 things all exist on their own conceptually. And so this is what we're going to deal with. This is the data we're going to deal with. We're going to make a crash driver info message specification. It's going to have a crash driver in it. They're going to be a driver. They're going to be injured. Potentially, they're a person. There's going to be a charge associated with them, and then we're going to have some information about the crash itself, just a date and coordinates of it. That's what we're going to do as part of our message specification. Now, this is what it looks like in business terms. Very simple and easy to follow. We just explained it. It's not a hard diagram. It's only 6 boxes. How hard can it be in NIEM? Well, let me show you. So if I convert that UML diagram to NIEM, and it doesn't all quite fit. We'll get as much as we can. Okay, this is what it looks like in NIEM. So when we do the mapping to NIEM, this is what we're going to get. We're going to get this diagram. And I know it's a little pixelated because it's shrunk down to fit on the screen. It's a big diagram. If you look closely, though, the different things that were in the other diagram are still here. you'll see there's still a person object halfway, a little more than halfway down in the middle there is a person object. And it's got a person name with first, middle, and last name, and it's got a person date. So those things are all still there. There is still a crash. It's right here. The date for it, though, well, you have to go up this chain of specializations and back down to get to the date. It's actually part of activity date. This is called inheritance. This is a topic for mapping. We're going to get to it in not too long, and you'll see how that all works. But the crash had a location. Well, that's over here and broken down into a bunch of things. It's not just a string. It's actually a structure of stuff. You'll see an association over in the lower right that links the person and the charge together. You got the charge down at the bottom. So all those different things that we saw in the simpler diagram are all here. But because NIEM is designed to take this information and break it into chunks that could be put together in different ways, things get broken up. Things get decomposed into smaller pieces. And those smaller pieces just end up being more complex. But when you put them all together, you're getting this conceptually. So this is the business view, and this is the NIEM view. And the whole mapping process is getting to this NIEM view. It's figuring out how all that easy stuff in the easy UML becomes this more complicated NIEM stuff. But you can see there's a reason for it. If I want to pull chunks of this out, things are broken up into boxes and organized more. So this is a framework for building stuff. But this is conceptually the stuff that we're going to build. And so this is the process of mapping, is getting from here to here. And in doing that, we'll learn all about NIEM and how NIEM works. But you can also see why I don't like to start with this, because I think this is a lot harder to digest and understand. And my feeling is, if you're paying me to help you do your exchange, I should be doing the heavy lifting to get to this diagram, not you. So, business people, you get to work with the simple one, and we will walk you to this one step by step as part of the mapping process. So what kind of tools do you want to use for UML? Well, you have a large variety of tools to choose from. There are tons of them out there. UML is a broadly used standard for diagramming different things. So there's tons of tools. The first one I recommend is called Argo UML. Argo UML is cross-platform, written in Java, works on almost anything. It is free and open source. It's a very common tool for NIEM work because it is free and open source and anybody can use it. So that would be my first stop, is Argo UML to draw UML diagrams. It's a nice program. Similar is something called BOUML, which I believe stands for Business Object UML. This is another free and open source UML editor. This one's a little more industrial strength. I haven't used it, but I know it's out there. I know developers who swear by it, so that is another option. If you want real industrial strength and you're going to do UML a lot, then you might want to look at programs like Magic Draw or Rational Rows. These are expensive. Okay? These are the kind of programs where you ask them how much it'll be, and they say, well, you got to tell us how many seats and we'll tell you how much you have to pay. It's one of those things where you essentially have to send in a request for proposal just to find out how much it's going to cost you. It is not just you pay X number of dollars. You have to basically give them information and they'll send you a proposal. Expensive stuff. If you're going to do this every day, all day, it might be worth it. If not, then the free ones are there. There are also general diagramming tools. Visio is a good one on Windows. So if you're on Windows, Microsoft has Visio. Visio is a great generic diagramming tool that can also be used to do UML and, of course, any other kinds of diagramming you want to do. So I've always been a big fan of Visio. I've used Visio since it was a separate company called Visio. So I actually bought Visio 1.0 long before Microsoft bought it. It's a really great tool. If you're on a Mac and you don't want to use Visio or you can't use Visio, OmniGraffle is the Macintosh equivalent of Visio. And OmniGraffle is also a really good program. These aren't free, but they're also not break-the-bank programs. You just go buy them, right? And your company might already have a license to Visio. So you take a look at that. But those are both really good general-purpose diagramming tools. And then if you're really a nerd like me, there are tools where you describe the graph in text, and then you have a tool that generates the UML diagram. And that's how I do it. So this diagram here, I didn't draw these boxes and draw the arrows. Rather, I wrote a text file that said what all the classes were and how they were related, with really just little arrows, little equal signs and angle brackets. And then the tools, this family of tools, will then generate the diagrams from the description. GraphViz is a very popular tool for doing this. There's a whole language underscoring it called DOT, D-O-T, and GraphViz is a general purpose diagramming tool. So it's kind of the equivalent of Visio in that you can draw pretty much any kind of diagram you want with GraphViz, including UML. Great general purpose tool. The next one is Mermaid, and Mermaid is a diagramming tool that, again, you type text describing the diagram and Mermaid will generate it. I like Mermaid because the note-taking app I use, which is what these materials are in. This is actually the program I use for all my notes, and I use it for developing the training materials, natively supports Mermaid. So I can actually put the descriptions of diagrams in my notes, and then when I look at it in preview mode, it will render, the note-taking app itself will render the diagram for me. It's very handy. Mermaid can handle a number of common diagrams. The sequence diagrams were done with Mermaid because it handles sequence diagrams. It's just very good at doing a large number of different UML diagrams. It does class diagrams as well, but I think Plant UML, which is specifically a diagramming program for class diagrams. I mean, it can do more, but it's very good at class diagrams, is what I use for class diagrams. And so I've described, and so this one is generated with Plant UML. Plant UML, I give it a description of all the boxes and what they contain and what they point to, how the connections are, and it generates that diagram for me. And Plant UML does a very good job of that. So if that's the kind of, if that's what you like, if you like, it's the same kind of cycle as writing code. You write code, you compile it, and then you run it. The same kind of thing. You write a description of the diagram, you render it out as a graphic, and you see if it's right. And if not, you go back and you fix your text. It's a different paradigm than actually drawing boxes and moving them around. You have a little less control, but for some people, these diagramming tools scratch the itch in a way that the actual diagramming tools don't. So try them out. Those are all free. GraphViz, Mermaid, and Plant UML are all free. Mermaid also is very good in its primary purposes for embedding diagrams in web pages. It uses JavaScript. So these are all really great tools, but pick the one that works for you. If you like drawing the diagrams by hand, start with Argo UML. If you got money to burn, start with Magic Draw and Rational Roads. If you really like writing a textual description of a diagram, start with, I'd start actually with Plant UML for NIEM work. And there are others out there. There are tons of UML tools in the world. UML is a big world. If you want to learn everything about UML, it's a week-long class type of thing. UML is a big world. Luckily, NIEM uses mainly just class diagrams, which are fairly easy to digest. Other business rules. So some rules are not easily represented in UML. The UML was showing us the different objects and what they were made up of. But what if you have other rules? Maybe you've got privacy rules. Maybe you've got security rules. Maybe you've got just rules like the birth date has to be in the past. Or if there's a birth date and a death date, the death date has to be after the birth date. Or maybe you want to check that a salutation for a person matches their sex. And these are all things that you can't really represent in UML, but there are other tools to let you do those sort of things. For some things, you can do schematron, and we're not going to talk at all in detail about schematron, but schematron is a way to define what an XML document needs to look like by making individual assertions. Assertions like a birth date must be in the past, or a salutation must match a gender by saying this element has to be this if this other element is this. Schematron is really good for that. It's a very technical topic, but you know what? If you don't want to do anything technical, you can just put a plain old description as well. You can just put that in your documentation. If I want to say birth dates have to be in the past, I can just put that in my documentation that, hey, birth dates have to be in the past. That's one of my rules, and that's perfectly valid. Nothing wrong with doing that. Not every rule has to be in XML. Not every rule has to be easily checked by a computer. And some rules are going to be checked by code. They're going to be checked in implementation rather than being checked by some validation routine built into XML and XML schema. So now we'll look ahead to the process from here on. So now we have some choices on how to proceed. because we've analyzed requirements. Now, we didn't actually go through that process. I mean, we could have if this were live and I had you all in a room and we could come up with requirements, and that would be fun, but I don't have you all in a room and this isn't live, so I can't really do that. So we made up one. We made up a message spec that we're going to use, a scenario to do, and I provided the UML for that, and that's going to be our guide. Now we need to decide the process we're going to follow for taking that UML and getting from that to NIEM schemas. So there's a number of ways to do that. Now, some people I know do all their mapping before they even look at XML and XML schemas. They will do all their mapping. They'll do an entire mapping spreadsheet. They'll be all done with the mapping, and then they'll start doing schemas. Other people will build schemas and instance documents as they do the mapping. So they'll map a few things, they'll reflect that in schema, they'll reflect that in an instance document. I used to do it that way, but it becomes a lot of work. Every time you map something and you get in a groove, you got to stop and you got to make some schemas and put a bunch of stuff in. It was a slow process that didn't let me get on a good roll. And what I've come down to for me is something in between. And this isn't the only way to do it. This is how I do it. And so this is how the training is going to do it. But it's not the only way. You do what works for you. That's a general rule for NIEM things. Do what works for you. NIEM gives you a process to follow and suggestions for how to follow that process, but NIEM doesn't make you follow a process. It doesn't make you really do much of anything other than follow rules to make sure your payload document is correct. So we're going to go through my way of doing it because I like it and I think it's a good way, and I think it works well for beginners as well as for experienced folks. That's what we're going to follow, but again, it's not the only way. So the way we're going to do it is as we do the mapping in our mapping spreadsheet, we're going to build a matching instance document, but we're just going to do it as text. And let me show you what it's going to look like. It's going to look like this. It's just going to be text. This is just plain old text, and we're just going to indent in to show the structure. So this is the end goal. Okay? How we get to this is the process of most of the training. This is the end goal, though, is as we go, we're going to be building this. And as you can see, this shows you the structure. It's very much like an XML document. In fact, it's almost trivial. It's not easy. It's grunt work, but it's trivial to convert this to an XML document. For those of you who do YAML, very close to YAML, all you'd have to do is put some colons and put some data on here, and it would be YAML essentially. It's just showing you the structure that we want to get to. So that is the process we're going to do. We're going to keep an instance document going as we go, kind of tracking the structure, and then at the end we'll make schemas from it, and we'll use some tools to help with that. There's a lot of tools to help. So before we go further, before we get into technical details, we need to talk a little bit about XML schema and about how XML schema works. Now, some of you may know. Some of you may already be experts in XML schema, but there's a good chance a lot of you don't. You were told to take NIEM training, or you have an interest in NIEM training, and you don't know XML, you don't know XML schema. There are tons and tons of XML schema training things out there. So, you can go ahead and pause and go and learn about XML schema. Learn XML schema in 30 minutes a day type things. There's just all sorts of materials online about how XML schema works. But we're going to give you a quick rundown here, just generally, so you have an idea how it works, so that when we look at the NIEM versions, it's not totally foreign to you. So, what you have in XML schema? Well, first of all, XML schema defines what an XML document needs to look like. There's also something called JSON schema. It does the same for JSON documents. You're going to find out you can't do JSON schema in NIEM yet, but that by the end of the year you should be able to. But right now you can't. We're going to focus mainly on XML schema in class. And here is a bit of XML schema. And what this is doing is defining a person name object. So here at the bottom, we have an element that we're creating. This is creating an element. Now, XML schema is written in XML, so this is what XML looks like too. But down here at the bottom, we're creating an element, we're giving it a name. We're saying the name of this element is person name, because that's what we're creating. We're giving it a type, person name type. So it's got a type. How do we know what a person name needs to look like? What can it hold? We look at its type. We have something called nullable equals true. And all that means is you could have that be an empty element if you wanted. It could just be person name with nothing inside. we have documentation for it, a definition inside these documentation tags. So this is defining a person object. But right now we don't know much about it. We just know it's got a name, and we know it's got a definition, and we know we can go look at its type to see what it's about. So where is its type? It's up here. Here's the start. Something called a complex type. Complex type holds other things. So this is an element that will hold other elements instead of an element that will hold data like a string or a date or a number. Here's the name for it. Person name type. Matches the type down below. This is the type of person name. This is where we go to find out what the person name could contain. We've got documentation tag. That gives us the definition of this type, very similar to the element definition. Then we have something called a sequence. And what the sequence says is something of person name type can hold the things in the sequence tag in this order. So we look inside the sequence to see the things that a person name could hold. And each one of these elements defines a thing that the person name would hold. So the person name can hold a person given name, which is a string. And after that, this is a sequence, so this has to be in order. After that, it could hold a person middle name, which is also a string. And after that, a person surname, which is also a string. We also have cardinality information. So what's the minimum number of given names that a person name can hold? 1. Has to have at least 1. So it's required. It's a required element. Has to be at least 1 person given name inside a person name. What's the maximum number? 1. Again, it's 1. So minimum of 1, maximum of 1. You can have 1 and only 1 given name inside of a person name. Same thing for person surname. It was min 1 and max occurs 1. So same thing there. But middle name is different. Min occurs is 0. That means it's optional. You don't have to put the middle name tag. That reflects reality. A lot of people don't have a middle name. My wife doesn't have a middle name. I do, but she doesn't have a middle name. No middle name at all. So you need to have that. You can't require a middle name. A lot of people don't have them. On the other end, the maximum number, unbounded. So that doesn't really mean an infinite number, because you have an infinite number, your computer's going to run out of resources. But what that means is there's no set upper bound. So your royalty and you got 3 middle names, that's fine. You can have the middle name tag 3 times. You got 8 middle names? Well, that's odd, but you can do it. You can have 8 middle names. So you can make it whatever value. Does it have to be unbounded? No, it could be 5. If we've decided we can only have 5, then we do 5. Suppose it was an address line. So NIEM has an address line, and your system only supports 3 address lines. Well, then exchanges to your system, you probably want to say, hey, you can have at maximum 3 address lines. So you have 1 as a minimum perhaps, and then the max is 3. So there are times where max occurs is going to be a number other than 1 or unbounded. It could be 5, it could be 3, it could be 12, things like that. Now, if min occurs and max occurs aren't there, it defaults to 1. So if this is just person given name and no min occurs and no max occurs, it's min 1 and max 1. That's the default. But in NIEM, we like to be really explicit about this. So when you generate schemas from NIEM, they're going to say, you're going to do the cardinality even if it's 1-to-1. So that's the cardinality part of it. So what we've learned so far is that a person name can contain 1 and only 1 given name, 0 to many middle names, and 1 and only 1 surname. Then the last bit here is an attribute. And the attribute is, it's an XML attribute. What do those look like? We're going to see when we look at the matching instance in just a second. But this attribute is named person name comment text. It is also a string. Attributes just have optional or required, so we're going to make it optional. And it's just a general comment about the name, whatever comment you want. So this whole block of XML schema here defines what a person name object looks like. And so that object is here. This is what a matching person name object would look like. Here's the person name element. Here's that attribute with a comment. In this case, we copied it from somewhere. It's just an attribute. It's just a comment. You'll see there's 1 given name. There are multiple middle names. So there's that middle name. And then there's this middle name. And then there's a surname. and then the XML to mark the end of the person name. And the whole thing there is the person name object, and it matches the definition in the XML schema. It matches how that stuff fits together. It tells you person name has a given name, middle, and a surname. It tells you the cardinality, so you know you can have one of the given name but zero to many of the middle name. It tells you what each of those name pieces can hold. They can all hold strings, and it tells you have that attribute person name comment text. Everything you need to know is there in the schema to be able to make a document that matches it. And so that's the role XML schema plays. Now the rest of the materials, we're going to be looking at XML schema as it comes straight out of NIEM for the most part. We're going to be making a little, but most of it is straight as it comes from NIEM to show you how NIEM helps you, gives you basically a framework to define the instance document, and the instance document is the thing you actually exchange.